Hi. Well, integration is full of ideas, so let's try to talk about integration of tan x and integration of secant x. Integration of tan x dx. As I mentioned at the beginning of explanation of integration, you have to make the function ready because this one is not ready. Tan x is one of the identities, so it should be written as sine over cosine. So in this case, I have to write tan x as sine x over cosine x dx. Now, it looks like rational functions and denominator is not linear, so I will go with the assumption u equal cosine x. So du over dx is equal to negative sine x, which means dx is equal to du over negative sine x. Now, if you go back to your integration, this will be integration of sine x over u times du over negative sine x. Simplify, and that would be negative integration 1 over u du, which means negative ln absolute value of u plus c, and u was cosine, so this is negative ln absolute value of cosine x plus c. So the integration of tan is equal to negative ln cosine x. Okay, what about secant? Integration of secant x. Well, secant x is a very special case, because even if you write this as 1 over cosine, that will not help. If you choose cosine, the derivative is negative sine, there is nothing to be done here. So I have to think in a very special way. In this case, I will keep secant x, but I will do something very special. In order to be able to use substitution, I need a derivative to be exist so I can simplify. So what I'm going to do here is to multiply all this by secant x plus tan x over secant x plus tan x. I'm multiplying by 1. All of this is 1, but I want to change the shape of the integration. How would that change of the shape help me? Let's have a look at what we will get here. This will be secant squared x plus secant x tan x all over secant x plus tan x dx. Now, it's a rational function. Look at the denominator here. If you choose it as u, what is u? Secant plus tan. What's the derivative of secant plus tan? Derivative of secant is secant tan, and derivative of tan is secant squared, which is actually what we have in the numerator. So if you choose u here to be equal to secant x plus tan x, which is the denominator, du over dx would be equal to secant x tan x, which is the derivative of secant, plus derivative of tan, which is secant squared x. So dx will be equal to du all over this. I'm going to write it in whatever, secant x tan x plus secant squared. The order does make a difference since it's addition. All of this now, if you take it and put it here in your integration, what will you get? You will get integration of secant squared x plus secant x tan x all over secant x, all over, we call this u now, right, times du over secant x tan x plus secant squared x. Now if you simplify, all of this will be gone with all of that. So you will be left with integration of 1 over u du, integration, what's wrong with the integration of 1 over u du, whatever. Now integrate this. This is ln absolute value of u plus c, which means integration of secant is equal to integration of what was your assumption, secant plus tan. So integration of secant will be equal to ln absolute value of secant x plus tan x all plus c. Same thing can be done with cosecant and cotan. You can memorize these as rules if you want. So in general, we can say that integration of tan x dx is equal to negative ln absolute value of cosine x plus c. If you apply the same thing for cotan, you will get integration of cotan x dx, which is ln absolute value of sine x plus c, because you're going to do the same thing. Cotan will be cosine over sine, and you will choose sine as u. So we'll reach to this result. Integration of secant, as we said, as we did, secant x will be equal to ln absolute value of secant x plus tan x plus c, and integration of cosecant x dx, we should expect that will be negative ln absolute value of cosecant x plus cotan x all plus c. And of course we know that the integration of sine is negative cosine, integration of cosine is sine. Well, I hope that this was helpful, how to integrate tan, cotan, secant, and cosecant.